Hello, it's another day, nice day, because I feel I'm finally ready to build me a power supply. I started it and I couldn't continue because I was using my old 60-watt soldering iron, this one, and it could barely solder anything. It's very old, like 2 years or so. So I got me another soldering iron because I could not continue this. And this one is one of those Chinese soldering irons in the market, and I just want to try it out also. It's just the same size as compared to that of the soldering station, quite small, but I think it should be good for our soldering here. Yeah, because we'll be soldering big components, and with a big tip, it's more heat transfer and it solders better. So see what we can do with this one. I just got it because it's looking good and fine. The tip is replaceable, but not with another size, of course. So we still have to deal with this one. It's nice, right? Because they made a smaller soldering iron that you can use even if you don't have the station. It's pretty nice, and we can also vary the temperature from here. Yeah, it's from 200 to 450. That's good. That's nice. So it is still connecting to the AC mains like the old one. But the difference here, it has a switch that is really okay because you can still switch off from here. Just holding it's more convenient though. You don't have to reach out for the the distributor, or the wall socket. So let's turn this one on from the switch and see. I have it plugged in, but I cannot see any lights. It's getting hot. Yes. It's getting mad hot. And it should smoke from its first use, right? That smell. Actually smells nice. Yeah, it's getting hot. Okay, something is wrong. I shifted the knob for temperature, okay, but it's on 450. So I think because we have like an arrow here. And that should be 450. Yeah. Oh, it was hot already. Yeah, that's one burn. I just burned my body. So I was distracted by the smoke. I was expecting to see smoke from its first use, but that didn't come out so soon. But now I can see it changing color. Yeah, let's try it for the first time. I guess it should be hot now. So I have my soldering wire here, the original one this time. Oh, that's fast. It's burning. Oh, nice. And it's burning very fast. And the solder is sticking on the tip. And when the solder is sticking on the tip, it's very nice because it permits you to easily solder the components together. when you have solder on a tip. That's good. That's really nice. I don't know how much you can see this, but that's okay. Let me get me something to clean. How do you clean the soldering iron? Yeah, that's a good question. Yeah, you see, this is what I used to clean my soldering iron, and it's the best. Trust me. The iron sponge. You know, it's actually bad to scrape it off like I see guys do. They are using a blade to scrape the tip right up there, and it doesn't end well. You either get shocked because you expose the coil somehow inside, and you can easily get electrocuted if you are soldering, and it reduces the efficiency, obviously. But if you clean it with the flux, the liquid flux, and this is perfect. See? Yeah, I can still stick solder on it very fast, and that's good. See? So that's how you clean the tip of the soldering iron, and I believe it's working fine. But I'm going to be using this old stand for it because it doesn't come with any stands, but it's still convenient to decide like that. Yeah, but I have to avoid pushing it way inside because it will it can accumulate heat on the body of the iron and burn the iron, the handle. So let's do the power supply. Okay, I forgot to put my mic on it. Yeah. So let's do the power supply. I started this some time ago. I have the components. I started this already, and it was going horribly wrong before I got my soldering iron just for that. So this is a schematic here, and it's good to use a schematic for building the electronics because you don't get lost at any point, and you easily understand what you are doing. Right. So this is just the first part of the circuit, the second one, and this one. So this first one is from the transformer. I have first the component that we'll use for this. We are going to use a transformer, a really big one, very big. So I got this one. Okay, first, so many stories. I'm going to. I think this one is good. It's good to finally build something that is usable for someone. I bought the the switching power supply for the workshop. Remember the 15 volts 2 amps. I was um I was quite hoping for something more, but I couldn't find it. 15 volt 2 amp, that's good, but I needed something like 30 volts. But what I found in the market is shocking. It's 30 volt 2 amps. I mean that's funny. How can you have a 30 volts and 2 amps? I mean you can find 24 volts 2 amps, but it's actually crazy to see an AC adapter for 30 volts and just 2 amps. So I didn't see that one to be really powerful. But this transformer, I got it from an old audio amplifier. It's very heavy, very heavy, and I guess it should go like 3 to 5 amps. Yeah, 3 to 5 amps. Yeah, and that's good for the electronics. The bench power supply is very useful if you have to if you have to let me turn this on. If you have to fix mobile phones, computers, laptops, and all that, it's very useful. So I'm going to be building a power supply, which is a linear power supply, not as sophisticated as the ones that I buy from the market, but it's going to do the job, and that is the most essential thing. It should do the job. I should be able to regulate the voltage. No, I should be able to vary the voltage as I want, and the current, control the voltage and the current, limiting the current, and have control over it. So we're going to build a power supply that is less sophisticated than the Chinese ones or the ones that we get from the shops. Um, but it's basically going to do the job, and it's even cheaper. Plus, you are having a good feeling that you are making something that is useful for you, right? So why I say it's cheaper, because you can really use any component that you have. You just have to find your way, play around it, see how it's working, and so on. Like my transformer here, I got it from. Alright, I'm talking without the microphone. Let me plug it in. Alright, so my transformer here is a really big one and heavy also. It's about I'm using the 30 volts output, but it goes up to 50 volts. I got it from an old audio amplifier, and the AC current we cannot test for now, but I think it should go from like 3 to 5 amps. Yeah, 3 to 5 amps, and so it's going to be a linear power supply. Basically, the transformer is the power supply, but the switching power supplies, like the one I have at the workshop, is a switching power supply. Yeah, it's a switching power supply. They are starting their circuits with the bridge rectifier, and then they use some kind of transformer also, and some how they call it, a short circuit protection. Yeah, they're using short circuit protections in their power supplies. So this one is not going to have any short circuit protection, but it's very useful for the repair the bench, and it's okay. We just don't have to short the things at the end. Okay, so I started this. Here is the schematic, the components first. So the transformer, I have two bridge rectifiers. I started connecting them, so I was building in air, and it was a total mess. Because I was using my old soldering iron. So I stick the two bridge rectifiers together. These are the bridge rectifiers. I'm using two because I want to be able to control the coil. I don't really know their rating, but I want it to carry as much current as possible. No, it's increasing the capacity if I'm connecting them in parallel. And I have transistors mounted on this heatsink. You can find this in the audio amplifier also. That's where I got it from. So you can find basically everything in the audio amplifier. Capacitors, resistors, because that's what I have here for. That's all what I have here for the power supply. I have this voltage regulator also with a high power resistor, capacitors. This is just another power supply that I made. It's going to power this special thing. I ordered this one from a parts reseller and it's amazing. It's good, but on my first try of this project some time ago, I blew one up. So I did a wrong connection and it killed it. So this is another one. I still have the, the plastic from it. So I'm going to be careful not to kill this one also. It's very nice. Can measure up to 100 volts, but current I'm not very sure. Yeah, but should carry a lot, right? Because of the display inside, should have like 100, but we don't need something like that. Okay, this is the only special thing that is in all the components. Everything is easily can easily get it from anywhere. So let's get building. So this is a transformer. This first circuit here is basically the transformer and the bridge rectifier here and the first capacitor. I'll tell you what that is. So on the transformer, we are having the AC mains right here. It's coming here. The AC, which we have 220 volt. Though it's a total mess, I'm not sure. Alright, so we have our AC input here, which is 220 volt AC coming to the transformer, and I'm using this this turn of the transformer, which is the 30 volt output. So it's stepping down the voltage to 30 volt AC, which comes to my bridge rectifier, and I'm using two in a parallel mode. So I connect the plus to plus, minus to minus, and the AC together for the two bridge rectifiers. So this is how the bridge rectifier. This one is just the schematic for the bridge rectifier. It's actually 4 diodes connected in some kind of configuration there. It's not that important, but it's good. The diode itself is looking like this. The bridge rectifier is having 4 legs. Here's the AC. No, it's here. It's written on the rectifier. We have AC in the middle. We have plus and minus. Yeah. So that's how the bridge rectifier is looking. That's it then. The transistor. I'm using two NPN transistors. This is the NPN transistor and it's a PNP. How do I know? This is the transistor here. It's having a base, collector, and the emitter, and it's basically working as our switch and voltage amplifier in the circuit. So we'll get to that. We'll use the transistor. So I'm using the NPN transistors for this. We are going to have okay, we're not there yet. So I have it soldered already. So we should measure 30 volts here. 30 volts. Easy. 30 volts. Yeah. So let me plug the power supply. I have a socket already. I have a socket already on the primary side of the transformer. Yeah. Okay, let me make sure I'm isolating everything here so that we don't have any shorts. Okay, so I have it plugged in. And I'll come with my multimeter. Let's check on the AC for the two bridge rectifiers. I'll set my meter to AC. From here to here, which is AC input, we have 30 volts. See? That's what we have, 30 volt AC there. And immediately we should have an output for a DC. You know, the bridge rectifier is working as it's basically converting the AC to DC. You know, if you are building the power supply, at the back of your mind, okay, multimeter is going to follow. On the back of your mind, what you need is something like this. So I drew it out here. Yeah. At the back of your mind, if you're building a power supply, you want a DC, a filtered voltage regulator that is used by the components in the devices. So on the bridge rectifier, we are having the AC input and we have an output from the bridge rectifier, of course, which is looking like this. But we want a straight voltage. Current. Yeah, that's a waveform of the current. So this is what we expect to have. But after the rectifier, we have some good amount of DC, but it's having a lot of noise. That's AC. Alright. I know I'm bad at explaining the things, but we'll just do it that way. So on the output of the AC of the bridge rectifier, we should have DC at what we have here, 27 volts. That's 27 volts AC. You see, we have the minus. It means we switch the probes. So if you come here, now we have 27 volts. So that is DC. Good. So we're building the power supply. It's working. And from here, what we have to do, we have to straight out the current. The current is not supposed to be looking like the way it is on the bridge rectifier. That's it there. So the way we can do this, we have to use a capacitor or a filter capacitor. This one. So I have two capacitors here, big ones, 470 microfarads, 200 volts. That's big enough for this, because on the power supplies, they are mostly putting the capacitors double the voltage. Like if I'm having 25 volts here, like in our case, I should have like a 50 volt filter capacitor. It's going to straight out the current pretty much better. So the capacitor is never larger. The larger the better for the capacitor. So I have a prototype board. I forgot to mention. I have a prototype board here, which I'm going to use alongside building in air. Building in air the other time was not very friendly, trust me. It was not very friendly, and I decided to get this board. So I'm going to mount some of the components on this board if possible. So So I'll desolder one of these capacitor. I was building an air, that is why I have a couple of wires on them, but I decided to use the board. I know I'm putting on a short trouser, so I'm actually burning my feet now. So the larger the capacitor, the better. It's better. So we can still choose to put two capacitors if you want 200 volts. But let me know if it has any problems. Now the capacitor is working. The capacitor is working as a small battery. You can say that. And this one of 470 microfarad should store up more current. But I don't know how that can affect our circuit. I don't believe it can. Right. So how are we going to do this? How are we going to do this? So we're going to have an output from this bridge rectifier from the plus and minus that is coming straight to this capacitor. Let's just start from anywhere. So I have to fit the capacitor into the holes. The holes are small. And yeah. So I have to stretch that out a little, the holes. I'll stretch the holes with this tester. I'm actually stressing to drill the holes. Why? Can I get me a screwdriver? Yes. Small one. Okay. This is a screwdriver. So let me drill some holes here. We have a big capacitor. Yeah, I might not use this screwdriver again. I know. Okay, so we have it like this, and the pins are out this way, and we can solder easily. Alright, but I don't know why I chose to put it right at the edge. No, it's not looking good. Looks like I'm managing the board, but I have enough. So let's put it somewhere here, so it's not going to be on the edge anymore. Can't wait to solder with this soldering iron. It's been on like forever. Okay. Plus and minus. You have to pay attention to the polarity of the capacitor. So I'm not just going to solder like that. I like to apply my best friend, flux. It's very important for soldering. Very good. It helps your solder to actually flow very well. enjoying. Okay, where is my soldering wire? Right. I just used it to test the soldering iron. Can be.